In this, our fifth segment, we will complete our work on position on the coordinate plane. In our last segment, we talked about shifting up or down by adding D. In this one, we're going to talk about shifting right or left based upon C, which will be subtracted from the input to the operation. And the operation, of course, we're talking about is some trig function. This, of course, was an add to the function. This is subtracting from the input. We will be getting to this later, the fun stuff. Today's pretty straightforward. We're going to start as we usually start, by looking at one of the functions and graphs with which you are most familiar and which I should be getting pretty good at drawing, but apparently I'm not. A parabola. Of course, this is the graph of the parent function y equals x squared, the very simplest quadratic that you could come up with. Now, what if I were going to shift this sideways? Suppose instead of having it with its vertex at 0, 0, I put its vertex, right here. Okay, let me draw this one in for us. So, say practice makes perfect. I'm a little ways from perfect, so I'm going to need a lot more practice. All right, the H is the horizontal translation. So it's H minus whatever the translation is. In this case, how far did I translate it? These grids are 2 by 2s, so we've got 2, 4, 6. This would be 8. It's right in the middle. So that is H is equal to 7. Therefore, it is x minus a positive 7. That's the equation. There's its graph. So that shifts it horizontally when you put, you subtract something from the input. Shifting horizontally, we're going to do this now in trig. Let me draw in the sinusoid here. We've got the parent graph for the sine function. And we're going to consider doing a horizontal shift. So if we want to shift it to the right, we're going to subtract the number of units we want to shift it from our input, our angle measure. What horizontal shift could be used to transform the sine wave into the same position as the cosine wave? All right, let's try it. Down here I have the cosine. How could I shift a sine wave? Now, of course, we know the sine wave starts out like this, but let's see, if I want to shift it so it has the same position as cosine, that's what I would do. Well, let me just draw in. I'm going to try making my line fatter. Suppose that will help me. I'm thinking it might. Okay, so it didn't help a whole lot, but there it is. Now what kind of a shift have we got there? What did I do? I moved it 90 degrees, didn't I? This point here is now over here. So I have a C which is equal to minus pi over 2. So that's minus a negative pi over 2. How would we write that? Y equals sine x plus pi over 2. So if you have a shift in this direction, you're going to subtract it. You're going to have, that's a negative shift, so you're going to have subtracting a negative, which is the same as adding. Let's see what I have right here. Whoops, I didn't pick it out. Yeah, negative pi over 2. This type of a shift, a horizontal shift, is referred to as a phase shift. So that's probably the most common terminology. Horizontal shift describes it perfectly. Phase shift is just the more common way of talking about it. State the cosine function as a phase shift of the sine function. So this cosine x is equal to what? We already figured it out, didn't we? Right here. That's right. What phase shift could be used to transform the cosine wave into the same position as the sine wave? All right, let me, here's our sinusoid. They're lovely, aren't they? Just a nice wave pattern. Now, if I want to transform cosine into sine, what have I got to do? Move it over to there, right? This is where sine is located. And then we'll think about what we've done. So here's the one I just moved. I took a cosine and I moved it into the position that y equals sine x would occupy. So I did move things. How much did I move them? Well, here was my peak right at 0, and now it's over here. So that was a positive, that was a shift of, our C is positive pi over 2, positive 90 degrees. So I'm going to subtract that from x. It's going to be x minus pi over 2 for my input to cosine. And we'll just check that. And we'll check that. So you've got this relationship now of sine and cosine. All you have to do is do a phase shift to get them to be identical to one another. Describe how the graph of the following differs from the parent graph. Okay, we'll talk about it. I know in our previous segment we actually graphed it, but let's just talk about it here. This negative 2 pi is going to do what to our cosine? It's going to shift it, right? Our C is equal to a positive 2 pi. So it's going to shift it a full period. In which direction? That's right, to the right. Well, let's look at this. If I start, remember where we were. So just the parent graph. The parent graph is, I wonder if I can capture one without the other. I probably shouldn't be messing around with this, taking up your precious time. Okay. I'm going to grab this and put it, I'm going to delete that, and I'm going to put this right here. Now, if I were to shift this whole thing 2 pi, that means this peak right here is going to end up over here. So let's do that. That's the green one I'm moving. Ends up right over here. I'll fill in the new information too. So now we've got minus 2 pi. And what happened? Actually, nothing that you can really see, because it's just laying on top of the parent graph. So what happens with this? It looks the same, doesn't it? And the reason for that is it shifted a full cycle. So without having to do anything more but think about what a full cycle is, what do you think about this one? What's a full cycle for tangent? Pi. So we've got a C here of minus, so it must be a minus pi. It's going to shift it this way, but it shifts it a full cycle, so it's going to also look the same. All right? On your calculators now, you're going to graph the following curves in a degree mode. And let's look at what the windows look like. Yeah, you should probably, for your window, what do you think? You want to be able to do both of these? I'd go from, for x, from, let's say, negative 90 to positive, let's add 90 to 360, 450. So from negative 90 degrees to a positive 450 degrees. That way you'll be able to see the shift on either one of these very easily. And what about your y? You want to go, we're not doing any shifting up and down here. Notice it's nothing being added to these functions. It's all being added to the input. So nothing added to the range, it's all being added to the domain. So it's just sideways we're going to see a change. So you can just have from negative 1 to 1 for your y. Now when we look at these curves, which have something being either, well, they have something being subtracted from the input, and that's going to shift it. If it's a positive value, it's going to shift it right. That would be in the form of x minus c. If it's a negative value, which would be expressed as x plus c, notice these are opposites, it's going to shift it this way. And of course, if c is 0, you don't have any translation at all. It gets tricky now. This is one reason I saved this for its own lesson. When you have a phase shift, the critical point angles change as well. These we're going to refer to as the true critical point angles. You add or subtract the phase shift depending on which way you're going to find the true critical point angles. So you start as you always did with critical point angles, and then to get the true ones where they're actually going to land on the graph, you add whatever that value of c is. It could be a negative or it could be a positive. So why don't you pause right now and go ahead and do both of these. Example 4, we can complete this one in class. There's a fair amount of work to do here, but just for the fun of it, does this one have any vertical translation? Yes, it does. It has vertical translation upward of 4. Does it have any phase shift? For that, you look here. Doesn't have any. How about this one? Does this have any vertical translation? None. Does it have a phase shift? Yes, it does. It's got a positive phase shift. When it's x minus, this is your positive, it's got a positive phase shift. It's 60 degrees. And a positive phase shift goes in this direction. So you go ahead and either do that now or plan to complete it in class. See you back in class.